In this video, we're continuing our work in section 3.1. After looking at our definitions of Riemann sums and definite integrals, we're now going to continue with example 3. In this example, we're going to again estimate the area under a curve, but we're going to make more sense of the context of what that area represents. So this question says, the graph shows y equals r of t, the number of telephone calls made per hour on a Tuesday. Approximately how many calls were made between 9 p.m. and 11 p.m.? Express this as a definite integral and then approximate with Riemann sums. So what we saw in some of the videos as well is that when we add up changes of a rate of change function, or when we're adding the area under a rate of change function, that accumulation is actually telling us a total amount. So in this case, we're looking at a function that is the number of telephone calls per hour. So if we add up the number of telephone calls we make each hour, then that should tell us the total number of calls made. So let's write out what it is we want in terms of a definite integral. So this number of calls made between 9 and 11 can be written as a definite integral because it is exactly equal to the area under this curve. So if we want to express that area in notation, we would say, well, it would be the integral from 9 to 11 of r of t. And then we're integrating with respect to this t variable, so dt. So now let's approximate that area using a Riemann sum. So we see that we could use two rectangles here, maybe like this and this, to approximate that area, but that's quite an underestimate. So rather than just using two rectangles, let's go ahead and use 4 rectangles. So we can see by looking at our interval 9, 10, 11, that our rectangle should have a length of 30 minutes or half of an hour. So we can do that a couple ways, change of x here. We could actually use that formula. So with 9 and 11, so 11 minus 9, all over 4. We get 2 over 4, which is 1/2, half hour. And we can also just see that on the graph. Okay, so our change of x is 1/2. So let's go ahead and use the left endpoints. So first, let's draw in those rectangles. So as we look here, are these areas going to underestimate, give us a smaller number than is accurate, or a larger number? A smaller number, because all of these rectangles are underneath the curve. So there's a little bit that each one is not getting. Okay. So now let's go ahead and estimate the heights of our rectangles then. So I'm going to call this rectangle R1, R2, R3, R4. So we have our x's and our areas. So what would be the endpoints of each rectangle? I encourage you to pause the video and fill in that first column. So if we fill that in, we'd have 9, 9.5, 10, and 10.5. Then the areas, well, the area again is going to be change of x, the width, times the function output. So r of, and I shouldn't be using x's here actually. Good catch, everyone. I should be using t's. So I'm going to have change of t here. Change of t times r of t. R of t sub I, let's say. So our change of area is always 1/2. We'll have 1/2 for each of these. And then now we can just look at our graph to approximate what those output values are, what the calls per hour is. So over R1, calls per hour is about 100. Over rectangle 2, our calls per hour is about here at That's about 125. Our next rectangle goes up to here. What? That's maybe 180. We have 180. Then our final rectangle all the way up at the top looks like it's about all the way at 200. So then we can compute each of those areas. So 1/2 times 100 would be 50. 1/2 times 125 would be 62.5. 1/2 of 180 would be 90. 1/2 of 200 is 100. So we can go ahead and add all of these up. And when we do that, we can consult our calculator or just add up each place value here. So go ahead and pause the video and add those up. And when you do that, you should be getting something around 32.5. 302.5. And that for us is going to be calls. And that's because our output value Y is calls per hour. So we're multiplying our change of time, that's an hour measurement. Our Y value is a calls per hour. So units here are hours times calls per hour. So the hours cancel out and our units are just calls. So then we can summarize by saying approximately 302.5. So we'll round up. So 303 calls were made between 9 p.m. and 11 p.m.